Dear children, welcome to the online class. Be safe and healthy. Thought for the day. One small positive thought can change your day. It's true. In the previous class, you people learnt the spheres of the earth, internal structure of the earth, and types of rocks. Today you are going to know about geomorphic processes in lithosphere. What is geomorphic process? The forces that act from the Earth's interior towards the Earth's surface are called internal process. In the geomorphic process, the force that act from the Earth interior towards the Earth's surface are called internal process or endogenetic process. Actually, these forces build the landscape and create topographic relief. The forces act on the surface of the earth due to natural agents like running water, glacier, wind, waves. These are called the external process or exogenetic process. Actually, in the process, two divisions, internal and external. The internal process, another name, endogenetic process. The external process, another name, exogenetic process. Like the two divisions are there. These external processes tear the landscape down relatively low elevated plains and shapes the landform created by endogenetic process. Internal process operate within the earth, drawing energy from heat. Yes, it generate heat and eject materials from deep below the earth crust. Internal radioactivity is the principal source of power for this process. Next, plate tectonics. The lithosphere is divided into a number of huge slabs of rocks. This is only called tectonic plates. What is tectonic plates? The lithosphere divided into a number of huge slabs of rocks, that it is called tectonic plates. These tectonic plates divided into major and minor plates. Two plates are there. Thus, they float independently over the mantle. Collisions of these plates produce mountain ranges and other irregular surface features, both on the land and the ocean floor. This phenomenon only it is called plate tectonics. The movement of the tectonic plates due to thermal energy from the mantle. Actually, about the mantle, you people studied in the structure of the earth. The plate movements and its relations to the earthquake and volcanic activities we can understand in this plate movements. Next, about the types of plate boundaries. What is the plate boundaries? How many types of the plate boundaries? Actually, the Three important types of the plate boundaries are there: divergent, transform, convergent. What is divergent plate? The two plates move away from each other. In the screen, it is clearly given in the picture also, children. Divergent. Here two plates it is given. In the plate boundary, it is move away from each other. The second one, transform. Two plates move past each other horizontally. See, in the transform plate boundary, it move past each other horizontally. The third one is convergent. The two plates collide. The two plates collide in the plate boundary. So, like the three divisions, the plate boundaries are there. Example of the convergent boundary: fold mountain. Fold mountain, which one? Himalayas. That's familiar as. Divergent boundary example: mid-Atlantic ridge. And transform boundary, or another one name, conservative boundary also. Here, San Andreas fault. This is the example of that. Next, movements of continental plates. Here in the screen, continental drift of plates it is given. Definitely you people can understand that what is in this. Here, 225 million years ago, how was the continent? 150 million years ago, how was the continent? As the same in the 100 million years ago. And how is Earth today, you can see. In the world map, you can see the North America, South America, Europe, Africa, Asia, Australia, Antarctica. In these continents, it is familiar to you in the Earth today. But other three maps, the continental drift of the plates, how it was 100 years, 150 million years, 225 million years ago. These are 100 million years ago, 150 millions ago, 225 millions ago. How was the maps and all? It is clearly given, children. About this only, we are going to know about the movements of continental plates. Actually, this is due to lateral compressional forces. The plates are forced to move upward and downward. Due to lateral compressional forces, the plates, which plates? The continental plates are forced to move upward and downward. This is called folding. The mountains formed by folding, that is called fold mountain. Already I said the fold mountain example, Himalayas in the convergent boundary. So the same here, due to the folding, by folding, the mountains are formed, that is called a fold mountain. It creates lofty mountain ranges such as the Himalayas and the Alps mountains also. According to the plate tectonics, the movements might seem slow, but over millions of years, the plates and the continents, it riding on them, move a long way. Example, about 250 million years ago, already in the screen, first map that only, the Indian plate was a part of the Gondwana land. 225 million years ago, the Indian plate was a part of the Gondwana land, which comprised of modern Africa, Australia, Antarctica, and South America. Is it clear, children, to you in this map? Approximately 140 million years ago, here in the screen, 150 millions given. 140 million years ago, the Indian plate broke away from the ancient supercontinent Gondwana, and it began moving north and collided with Asia. What is happening there? The collision with the Eurasian plate Along the boundary between India and Nepal, it formed orogenic belt that created the Tibetan plateau and mighty Himalayan mountains also. Now we are clear now children how the Himalayan mountains formed, how it was created. Clear? So between India and Nepal formed the orogenic belt, created the Tibetan plateau and the mighty Himalayan mountains. Okay, so it happened in the plate boundaries. Next, about the earthquake, it is also related to that only. We people know about the earthquake. Earthquakes generally, whenever we are telling about the earthquakes, definitely the vibrations is happening in our heart. Isn't it, children? Yeah. The earthquakes are generally caused by the sudden vibrations in the earth's crust, which spread outward in all directions as waves from the source of disturbance. It given the great vibration, the sudden vibrations in the earth crust. The point of origin of an earthquake is called focus. See, in the screen, in the core part, it is mentioned the focus. And that is the hypocenter, which generates a series of elastic waves. And another one, it's written children, epicenter, is a point on the earth's surface. It lies directly above the focus. Yes, epicenter is above the focus. The impact of the earthquake is felt the most at the epicenter. Okay, ma? The next about the seismic waves. Here in the picture, the example of the earthquake affected area, the building how it is. Here in the road, the starting of the earthquakes. The next about the seismic waves. What is seismic waves? The energy waves in an earthquake that move outward from the focus and make the ground quake. In the focus, the point in earth interior where earthquake energy is released. Already I explained in the first epicenter and the focus. What is focus? The point in the earth's interior where earthquake energy is released. Okay, in the picture also it is given very clearly children about the seismic waves radiates from the focus of an earthquake. Earthquake generate seismic waves. The nature, force and speed of the seismic waves depend on the nature of the medium through which it passes. Accordingly, three major types of the waves, that P waves, that is primary waves, secondary RS waves, surface waves or L waves. Like them, three important waves it is mentioned. Primary waves, how it is? See the screen. The waves of energy that travel through the earth by causing particles in rocks to compress and stretch apart in the direction of the wave. That is P waves. Secondary waves, waves of energy that travel through earth by causing particles in rocks to move at right angles to the direction of the wave. That is secondary wave. Actually, the primary waves, the fastest of all earthquakes waves and the first to reach the epicenter. These waves pass through solid, liquid and gases either through push or pull with an average velocity 5.3 km per second to 10.6 km per second. So that much of the fastest of all the earthquake waves, and it reached to first in the epicenter. Secondary or S wave, it travels only through the solid. These transverse waves shake the ground perpendicular to the direction in which they propagate. The average velocity of these waves 1 kilometer per second to 8 kilometer per second. Here in the screen it is given, children. S waves are secondary waves. The transverse are shear waves. These waves are slower than P waves and it can only travel through a solid. It travel through the solid. They do not travel through liquids or gases. Okay. The next L waves. The surface waves with the characteristics of both the transverse and the longitudinal waves. The ocean waves are a prime example of surface waves. The paths of individual particles are circular. The L waves are similar to P waves, but they travel primarily along the ground surface. These waves travel comparatively slower and the most destructive waves. Destructive waves, which one? L waves. The average velocity of these waves 1 kilometer per second to 5 kilometer per second. So about the three important seismic waves I explained to you, children. And two more important, do you know the fact also I should say to you. Do you know the actually the C.F. Richter, a person, he devised a scale to measure the magnitude of earth. See in the screen, children, earthquake magnitude scale. The scale relates to the energy released at the epicenter and it provides an estimation of the severity of an earthquake. It is an open-ended scale. See, it is, children, here 2, 3, 4, 5, 6, 7, 8 like this. It is according to the damage level and the point it is given: minor, light, moderate, strong, major, great, like this it is given. 2.5 or less, it is usually not felt but can be recorded by the seismograph. And another one, 2.5 to 5.4, it is often felt but only causes minor damages. 5.5 to 6.0, slight damage to the buildings is happening. It is actually used to call the moderate level. 6.1 to 6.9 may cause major damage in the populated areas. It affected in the populated areas, it causes. 7.0 to 7.9, a major earthquake causing serious damage. Maximum, if people know that earthquake, it's a severe damages to that in the point. In the great, it is mentioned 8.0 or greater. The measurement, a great earthquake that can lofty destroy communities near its epicenter. It's a very greatest damages it's given to the level. Then another one is the instrument which record the earthquake. Generally, which instrument used to the earthquake? Basically, we people know that. But here, children, we can see how it is working. The vertical seismograph with the generalized. And here, already what we studied, P wave, S wave, L wave, how it is working here. P and S waves behavior. It is supported to the P wave compressive and S wave shear and spring, mass, frame fixed to earth. So everything we can see how it is working. So the instrument which records the earthquake waves is called a seismograph or seismometer. The science that deals with the earthquake is called seismology. Is it clear, children, to you? Okay. I hope you people understood the lesson and go through the lesson. Okay. So, you people in this lesson about the geomorphic processes, the internal and external, plate tectonics, the types, plate boundaries, convergent, divergent, and transform, and the movements of the continental plates. And very important, they very clearly learnt about the earthquake and the seismic waves also. So I hope you people understood the lesson. Okay, children. Thank you, students. Be happy and safe.